Okay, Mr. Wiggins gives his daughter Celia two choices for payments for raking leaves. Choice 1 is $2 for each bag of leaves filled, or choice 2, she'll be paid for the number of bags of leaves she rakes as follows: 2 cents for filling 1 bag, 4 cents for filling 2 bags, 8 cents for filling 3 bags, and so on, with the amount doubling for each additional bag filled. And then it starts asking us questions. If Celia rakes enough to fill 5 bags of leaves, should she opt for payment method 1 or 2? What if she fills 10 bags of leaves? In general, which payment should she choose if she knows how many bags she plans to fill? So it's asking us kind of 3 questions. Here's question number 1. I'll label it A. For 5 leaves, which plan should she take? For 10 bags, which plan should she take? And then in general, if she knows how many bags she plans to fill, which payment method should she choose? Okay, so again, I'm going to write my answer in the box here, and I'm going to start by defining my variables. Notice that it asked me to justify my answer with words, tables, graphs, and or equations. So I'm going to define my variables so I can make a table for each of these options. I'm going to define x number of bags Celia fills, y amount of money she gets paid in dollars. It's important because they're talking about dollars in option 1 and cents in option 2, so we need to have a unit for this. Because I'm going to make 2 tables. I'm going to make a table for option 1. Option 1 is pretty simple. If she fills 0 bags, she gets $0. If she fills 1 bag, she gets $2. She gets $2 for each bag of leaves that she fills. So 2, 4, 3, 6, and so on. I'm quickly going to write an equation for this because it's pretty simple. This is linear, right? This is going to be equal to y equals 2 over 1x plus 0. Really, the plus 0 part isn't needed, but it's fine to have it there. Here's option 2. We have x, y. Again, if she fills 0 bags, she's not going to get any money. If she fills 1 bag, it says that she's going to get 2 cents. So this is in dollars, so this is 0.02, 2 cents, or 2 divided by 100. For 2 bags, she gets 4 cents. For 3 bags, she gets 8 cents, and so on. So I'm going to add one more entry here. Um, 16 cents for 4 bags. Okay, so it seems kind of like a no-brainer here that for Celia, option 1 is making her a lot more money. But take a look at what's happening here. We've got this is doubling. Next she's going to get 32 cents. Next she's going to get 64 cents. Next she's going to get over $1. And then it's going to keep doubling. So if she plans to fill a lot of leaves, this is eventually going to get to pay her quite a bit. If she's only filling a few bags of leaves, this right here is obviously the way to go. It asks for 5, and for 5 bags of leaves, she would make $10. You could find that by either extending this table or by plugging 5 in for X here, and 5 times 2 over 1 is 10. So $10 for 5 bags of leaves. For option 2, for 5 bags of leaves, she's going to get 32. I think I'm just going to carry this table out a little bit. 6, 7, 8, 9, 10. So this is going to be 64 cents. This is going to be $1.28. I'm just multiplying by 2. This is going to be $2.56. $5.12. $10.24. So you can see this is starting to get pretty big. The next one's going to be like 20. So 11 is going to be $20.48. For this option for 10 bags, so I'm just going to circle the things they asked me for. For 10 bags, again, I could plug in 10 for X, because X is the number of bags that Celia fills. And I would get, for 10 bags, I would get $20. So still, at 10 bags, it's better for her to choose option 1. But you can see this is getting big fast. So let me even keep going here. For 12 bags, it would be $40.96 that she would make. And for 13 bags, she'd make $81.92. And so on. I'm just doubling that each time. So you can see it's getting big. Whereas, just to keep going here, 11 bags, she's going to make $22. So for 11 bags, it's still better. Option 1 is still better. For 12 bags, she's going to make 24. But for 12 bags in option 2, she's going to make $41, $40.96. So 11 bags is kind of where this is where it gets better for her to choose option 2. Okay, and I'm just going to really just sketch a graph showing, because I'm going to use this in my explanation, showing these two options. And what we're seeing here is option 1, it's linear. Whereas option 2 is exponential, and it starts really, really slowly. But then it starts going up pretty fast, and eventually it catches option 1. So this is option 1. This is option 2. And this right here is between 11 and 12 bags. That option 2 catches up with option option 1. So this is the money. This is the number of bags. So that's a lot of tables, graphs, equations, and now I'm just going to write some words to explain. So for 5 bags, actually I will write it and then come back on camera. Okay, here's what I wrote to go along with the math representations I've already shown. I said for 4 bags, she should pick option 1 because it makes her $10. Option 2 makes her only 32 cents. For 10 bags, she should still pick option 1 because it makes her $20. Option 2 makes her only $10.24. And then the answer to the third question, in general, if she plans to fill more than 11 bags, she should pick option 2. for 12 bags or more, I'm going to make that option 2 to be really specific, makes her more money. See the graph. So I just pointed the reader back to the graph showing where option 2 takes over option 1. You'll notice that I kind of squeezed in my answer here. If I was doing this on the actual test, of course, I'd be writing in pencil, and I would probably erase and make my writing smaller so it could all fit. I think this would be okay because it's not outside the box, but any writing that you do outside the box won't be read. A problem like this will be read by a human being, not a computer, but they won't read outside the box.